Hi, my name is Jason Slubber, and I'll be guiding you through some of these setups that Omar generated to create the shots and the effects within this trailer. We've got quite a bit of interesting setups going on, like the traces. That's quite a unique setup, and then our lightning setup and shields, etc. Some really interesting techniques that we're going to be looking at. So let's have a quick look at the course overview again. And so week one, we're going to be looking at the project setup and have a look at the directory structure of the actual shots and the USD exports and how that is being set up. Then we're going to move on to a little bit of a workflow, and this is largely to do with the USD setups and how we take stuff from SOPs and load that in. We're going to be looking at some motion blur potential issues and how we handle packed geometry and instancing, etc. And then we're going to move on, get stuck into the actual shots of the course. We're going to start developing the first shot of the trailer where the robot goes into the cloaking. And so we're going to continue with week two on the cloaking effects. We're going to take it a little bit further, add some additional passes. We're going to be looking at a LOPs render setup just to look dev the layers that we'd need to render for compositing. And then while we're at it, we want to have a look at how those renders might play out in compositing, and we're going to do some R&D compositing in Copernicus just to get a look dev feel and make sure we are putting the correct kind of layers that compositing might need. Then moving to week three, we've got quite a jam-packed week there as well. And this one is for the shot 9. And this is where the mech is shooting at the robot, and the robot basically flies in front of us, and he boosts forward up into the air using his thrusters. So we're going to be creating the thruster effects and the trace of fire, which is quite a nice setup. And then we've got some muzzle flash setups, that's volumes, and then some additional sparks that we're going to be creating. And then finally, we'll just briefly look at how we can bring those objects into LOPs as well and set up some quick renders. Week 4 is pretty much what you're seeing on this screen here. The background and the previous shot is where we will see the laser beam and the ground destruction happening. It's quite a nice one as well. And then this shield, that's really nicely done with the shield effects here. This is a really nice shot, so looking forward to getting through this one. And then in week 5, we're going to move on to some of the other stuff, and we've got the EMP and the lightning effects that's done. This again is quite a unique setup and a really interesting way that it's set up, that the lightning travels across the character's body. And we've got a force field that shoots outwards, and a lot of this stuff is, we're using the lightning effects in different ways. So we'll be looking at one or two shots to see how that translates across the different shots in week 5. And then in week 6, we're going to be looking at this shot again, pretty much. And this is the rendering and compositing of this shot and how that all comes together. And then in week 7, we're going to be looking again at some more rendering and compositing stuff. And this is again, this is our shot 2, which is our reveal, a cloaking setup, and how that composite came together. And then finally, in the week 8, we will be looking at just a bunch of variety of the different shots, and touch on some of the other stuff that came across during the rendering and compositing side of things. Just wanted to point out that some of this stuff might change, especially in the later weeks. We will be covering everything that's here, but the weeks might shift around a little bit. And I just wanted to point that out. So if you're referencing this specific layout here, what you can expect in the weeks, there might be some tweaks going on as we're still recording this current part, the last part of this show is still being recorded. So as we develop it, we might just move things around a little bit, but we'll definitely be covering everything that's here, just not necessarily in this order. All right, so the next thing I just wanted to move on to was the Houdini that I'm using. And for this, I'm using a educational license. And why I wanted to point this out specifically was because you might be using, well, you could be using a non-commercial version as well, which is fine. And then you could also be using indie, or maybe you've got access to a full license. And what's going to happen if you take some of my files, and even if you copy a node out of a educational or non-commercial into a Houdini indie file, and you save that indie file, it's going to become a non-commercial version. So just something to be aware of if you're going to, perhaps copy some of my setups to speed things up, and you're using indie. I wouldn't want to then change your setup into a non-commercial by accident, and then you're going to have to redo that work. And the reason why you might not want it if you've got an indie is obviously then you're going to have watermarked renders if you're using a non-commercial version of Houdini. Then the other thing I will be using a little bit of is the Houdini side effects labs. So when you're doing your Houdini install, make sure you have this installed as well. They've got some really handy tools. It's always just worth installing by default anyway. The last thing I wanted to point out is just our Discord channel, and definitely join this. We're going to obviously help out people as things progress. And obviously this is me. We've got Gavin and Andrew, our training assistants, and they will try and help out as much as we can as well. So just another thing I wanted to point out here was that we obviously all are in different time zones. So if you do message us and we don't reply, within a few hours, then, please forgive us, because we might be sleeping or somewhere else. So just, have a little bit of patience, but we'll definitely get back to you. And if you don't hear from us, maybe there's been a lot of messages in the Discord, then feel free to just, re-ask us again, or just, ask the question above again. Then the last thing I just wanted to also just mention is if you could please keep the DMs to a minimal. And that's not because we don't want to receive DMs. The thing that I've found just over time is that a lot of students ask the same question over and over. And, I specifically, someone asking me the same question, and then like a day later, someone else asks me the exact same question via DM. And if they had asked in the main forum, then, well, there's that answer would be there for everyone. And since we're all learning this project at once, it makes sense to try and keep it all aligned within the thread of the Discord channel. And that just makes it easier, perhaps, even if we don't see you asking the question, somebody else that might have had the question answered already can help and reply. And that way we all kind of becoming a little bit of a team and working together to get through any potential issues in the project. So with that being said, let's get started and get cracking with the course. So just another quick overview of week one. I'm obviously not going to spend too much time on this. We spoke about most of it already. But yeah, so you can just read through this if you want to pause here for a bit and have a look at it. But I think let's get started with the project setup and have a look at some of the directory structures that we're going to be dealing with. Okay, so I've just loaded up Houdini. This is pretty much a fresh install. Default build I've got here. So yeah, if you've just installed it, you should be seeing the same kind of look. What I want to do first is let's have a look at, we've got this create new project and set project we can utilize. And if I open this up, it gives me a path and a project name and a whole bunch of folders to look at. So now just going to my directory structure here, my FX training. So this is where mine is located under FX training. And just looking at these folders, this is the folders we've got for the shots. And pretty much we'll be supplying these. I don't think we need this geo, that's an old one. I'm just going to move that here. So this other folders we don't need. What you'll need is the assets, possibly the captures, and we need this LOPs one, and then the shots. And having a look at these now, diving into the assets. So these are all the assets for the animations of the shots. So we've got shot 2. Within shot 2, I've got my camera, I've got a specific barrier and floor placement, and then I've got my character robot animation, which is an alembic. And then going to, say, shot 3, the same thing. We've got the character environment. Shot 4, let's go up to maybe shot 9, where we've got 2 characters. So I've got a camera, character 1 and 2, and then we've got some environment exports here as well. So those are all the assets for all the shots. You'll be receiving this assets directory as is, and as well as this LOPs to Sci-Fi. Now this LOPs Sci-Fi setup, this is where we built all the Alembic and the USD workflows. So if you dive in here to this barrier 1, you'll see there's a HIP file, and we've got some textures, and we've got a USD export, and this is what's been exported from the file, but we'll have a look at some of these in a moment. And we've got our soldier here, same thing, same layout. We've got geo, and these are the original like FBXs or ABC files that come in, and then those get built up in the HIP file and exported as this USD for later use. And then just going back to this directory up here, as you can see, we've got some other stuff going on. There's also this shots directory, and this was set up to do test lighting for setups for all the shots as well. So you'll be receiving that. So it's got the USD exports for the cameras and everything here as well. Just having a look at, here's all the shots. We've got some single frames rendered. So having a look at those, these were the renders that those files basically used to render these lookdev frames. So you'll have access to all these lookdev files, which is quite nice, and you can see how everything was built up. But we'll take a closer look at one or two of these, maybe the concrete barrier and the soldier setup. We'll have a look at that and see how those flow. And going back to the main directory, so we've got our assets and then we've got our shots that we're actually going to be working in. So this is basically where we're setting up our effects. So effects, I've got, and we'll be building this as we go. So you'll be receiving, for instance, a start and a finish file. Obviously, I'd want to encourage you to hit the start one. We start with basically just a blank scene with some base setups of the assets, and then we start building the effects from there. And so moving on then to, for instance, shot 9, same thing that we've got that. So these are the shots that we're receiving. So this is kind of our directory structure that we'll be working with. And so you can see there's a lot of stuff here that we don't really need, going back to the setup. So we don't really have to use this project setup. What we can actually do is come in and just set a environment variable. So if I come to my edit and I go alias and variables, and if I go here to the variables setup, you can see by default there's not much going on here. I've got this HIP file, and then there's a job, and this is just pointing to my default users JSON. So if I come back to my project here, and I, for instance, right click and I copy this address, what I can do is click on job and I can paste this address in. Now, before I press enter or anything on the keyboard, I'm just going to make sure I change these slashes to / like that. And if I go to the end here and I press enter on my keyboard now, you can see this job variable is set to this. So this is quite handy. Now this specific Houdini session has got this job variable set to the basically the project path, which is job. So in order to just to get started and save a setup, we're going to go to File, Save As, and what I want to do is come to my project, and we can just actually save a file here. So for instance, this can be untitled, but I'm going to just call this blank and save like that. So now if I go to File, Open, and you can see my hip now is pointing to that. If I go to $job, it's pointing to the same location, as well as if I go to my environment variables, I've got my hip file now sitting at that location. And also when I start building on a scene, I can just make sure I have this job variable set up here. And you could also go to set project, and you can set the directory over here as well. And that should also, give you that alias and variable set up with a job set up over here. So the last thing I want to do is just change the desktop up a little bit. And the first thing I like to do with Houdini is get rid of this blue. So pressing D on the keyboard, I'm going to my background, and I'm going to change this to dark. I just find when you're doing especially effects, the effects stand out so much better on a dark background. So I always just prefer to work like this, but obviously that's user preferences. Now then, just looking at simplifying this desktop, I have got a saved desktop already, and what I generally do is just come in with a new one. I just delete a lot of these tabs that we're not going to be using. It's like render view. This is the old renderer. Animation editor over here doesn't make sense because you want to be able to see your animation editor while you're doing stuff. So I take that off, and then we're just left with the scene view. This take list we don't need. This is old stuff. Performance monitor you could leave if you want to check stuff, but in this case I'm going to remove it. And then we're just coming back down here. So there is two partitions up here, and obviously when we create a geometry, we have our parameters up here and our network view. What I do like to do is make my network view a little bit bigger. So essentially what we can do is we can come here and we can close this pane. So now we've just got a viewport and a network editor on this side. And then hovering over here, we can press P on the keyboard, and this will bring up this parameter editor that we can utilize here. And this is quite nice because you can just make it quite small, and you've still got then your whole network editor on this side. And then the last thing what I want to do is over here I want to expose my geometry spreadsheet. It's very important to always have a geometry spreadsheet available to you. So what we can do is we can come up to this little icon, and then we can split the tab top and bottom, and then we can right click on the scene view, and we can go to inspectors and geometry spreadsheet, and maybe just push this right down like something like this. And then you've got your information here always available to you. You can collapse it quite easily like this. And that's pretty much the base setup that I like to use. You can leave your shelf tools depending whether you like to use them or not. But you can also come right to the end here and you can collapse them out if you want to do that, just to give yourself a little bit more real estate. All right, so the last thing then would be just to obviously save this desktop if you got it. I've still got an asset browser here. I'm just going to close that as well. And this, I'm going to close all those tabs. I don't need any of them. It's just to save your desktop, and that would just be coming in here and saying save current desktop. And that if you just do save, it's going to save over the current build. So if you want to keep that, you might want to do save current desktop as, and then you could give this a name that you want to call it. Like I said, I've got mine's called _JS. And yeah, so that's pretty much my layout. And then the other thing what I wanted to note is if you want to always use this desktop every time you load up in Houdini, you need to come to your preferences, and just under the preferences, I think it's under the general, yes, under the general top one, there's a set startup desktop, and this will always default to build, but you can set it to your one that you want to use. Now, the other thing, just before we move on, I wanted to point out the other context we're going to be using is our stage, obviously, our LOPs. And just looking at that, and I'm just going to create a grid here, just a piece of geometry to open. We do have a specific desktop that you can use for Solaris, and this is the new one, this Solaris look dev. I do find it very cluttered, so but this again is, you know, it's up to you. Some nice things about it, because it gives you some built-in stuff that you can do with Solaris, and then it's obviously got your stage kind of manager of sorts here, or your scene graph tree up here, and then you've got everything down here. But what's nice, if you just want to stick to your one that you set up, is it still works fairly well. So you've got your little scene graph tree that gets the spreadsheet gets replaced by that. So you've still got the same layout, and you've still got this bit of information here that you want. And so that's quite handy. If you wanted the render view, you could come over here and we could go to Solaris, and we could say add render gallery, and that will be available to you on this tab then. The other thing to note is what we want to do is make sure we've got our color display on, especially for rendering. So if you hold down on this little eye here, you can see there's a color correction. Just click on that, and you see we will pop up with our color correction. We generally going to be working in sRGB and with the ASUS, by default, the ASUS SDR video LUT or look applied to it. So that's, you know, quite handy to just make sure that you're looking at the correct stuff. And then lastly, just before we move on, I just wanted to point out the frame ranges of the actual trailer. These shots were set up sort of in a sequence. So for example, frame or shot one might be, say, 48 frames long. So we'll have a 48 frame animation, and then shot two might be, you know, maybe up to 100 frames or something. But that will start at frame 48, shot two to wherever that takes us, maybe to 120 frames. And then shot three will start from that, the camera animation and stuff. So just something to be aware of if you load up a camera or animation for a character and you're not seeing anything down here. It might be that it's offset quite high. So if, like, you know, if it's shot like 19 or whatever, something like that, it's going to be quite far along, like frame 2000 or something. So just something to be aware of. All right, so with that being said, let's move on to the next section. Okay, so the first USD setup that I'm looking at is this concrete barrier one. I've opened the file here, and I'm sitting in the stage view. Now you can see there's quite a bit of stuff going on here, and just starting out at the top. So this layout, pretty much this section I've selected here, is been set up as like a generic setup. for all the assets. So what happens is you bring in your assets, you prep it, and then you just run it through this setup. At the top here, you've got an asset name that points to your USD. In this case, it says hip file, which should probably set this to job. And yeah, with the name of the output. And at the bottom here, there's a save asset, and that is referencing all those bits of data there. So you can see if I middle mouse on there, it's giving that output. And then over to the side here, there's some lighting stuff, so you can test the lighting and the shaders on this. Just give this a bit of a render and see what it looks like. So at the moment, it's loading in a map here, but yeah, the map is pointing to the incorrect place. So let's maybe try to set this to something else. I'm going to go to my $job, and there is a environment. There's an overscan here, and let's just switch the input to this setup and see if it loads. There, we're loading now. So yeah, you can see it's loading. Got this kind of daylight over. It's quite bright, but you can see all the textures and everything's working. So all right, I'm going to cancel this. So just going back to the setup over here. So this setup is pretty much like the component builder that you get that ships with Houdini. So there's a lot of stuff going on in here that you don't really need to know about unless you're really building USD systems from scratch and you want to know exactly how they work and how they're structured. But to the most part, to do this whole setup here, you could use the component builder, and that would make your life a lot easier. You've got your geometry coming in. So if we have a look and we go inside the SOP network, we've got our geometry coming in. We've got an output render. We've got an output proxy here. If you look at the component builder on this side, if I double click in here, you can see I've got output. I've got my proxy and some geometry. So you can just input your file here, and it will pipe through the setup through this. And then just looking at the scene graph tree here on this, if I go down to the select components, you'll see I've got my component output, which is named this. Likewise, if I go down to here, if you look at the structure here, so I've got a geo material. If I go down to the bottom of this, where just before we write it out, I've got a couple of extra things, but at the end of the day, there is a geo. I've got a proxy there and a render, and then I've got my material as well. So similar, slightly different structure that's been added to this, but very, very much the same thing. And yeah, this is just a pre-built version of this, really. If you dive inside it to some of these setups, if you go into the network inside here, you can see there is a whole bunch of like primitive configures and stuff like that, and going all the way down to this component builder. Going inside here, if I click on the component output, you can see I've got these layer breaks and renames and all sorts of stuff. So probably a little bit more than what's going on here, but obviously this is a lot more automated. But what I'm trying to say is just that this is probably a lot simpler. And if you really want to get into the nuts and bolts of how USD works, then you might want to learn how to set all these things up manually. And you could, for instance, even go into these. If you unlock these, allow editing of contents, go into them, and you can go ahead and rebuild this setup and see exactly what they're doing. So we've got like a render purpose here, proxy surface, etc. And yeah, so those will all come through in a similar fashion to this. We've got our inherit classes and all sorts of things here. So yeah, that's what I wanted to just point out, that this is like a pre-built setup, and we've got a very similar setup. If you wanted to rebuild any of this and in a simpler fashion, you could very much just use this setup. So going and opening, and let's just look at another one. So I want to use the soldier here, and let's look at this one. So I'm just going to discard that and open. And again, you can see the exact same setup. So I've got my asset name and where it's pointing to, and writing out over here. So, and then this is obviously our static soldier. He's been set up in his rest pose. So going in here and having a look, we've got a proxy render and all the setups in the actual process geometry. We've got a bunch of stuff going on in this, but this is just cleaning up geometry from the Limbic file. Nothing really to worry about from your side. So this is just prep work that's been done just to allow the shaders to work nicely and stuff. So what we can do is, like I said, this is just static. It's a static object. If we render this, it's probably going to give us some red lights again as well, because we don't have maps here. But the nice thing about this now is sometimes this thing disappears. Let me just reload this, check the lighting. So what's nice is we're saving this out as a USD, and you can see I've got my whole setup here. There's quite a few names here that's probably not necessary, subnetworks, but I've got some lights in here, and this all gets saved out with the USD. You've got my materials, and that's really handy. So when we actually get into the shot work, what we're going to be doing is creating a sublayer system. And we basically taking this mesh with all the assignments to it, the materials, and then we just applying the animation, basically deforming the geometry with animation. So it's sublayering animation in, but keeping all the materials, etc. So that's the nice thing about USD. You can layer things up like that, and it gives you quite nice flexibility to be able to build these assets and finalize the assets and continue working on them while animation is still happening. So the last thing I want to point out before we move on, I want to just open up a shot and we can see how the sublayering works and how we bring in all the assets. Is if you've loaded up your file here and you actually don't see the robot in here, there is what we call purposes being set on here. And at the moment, this is a render purpose. So if you don't see it, there's these little sunglasses. And if you click on the sunglasses, you can see there's a render, proxy, and guide. If I turn off render, you won't see anything. And this is possibly what you're seeing if you don't see your geometry. However, if I switch to Karma XPU, you'll see now I get a render of this character. And that's pretty much because the USD purpose picks up when you render, it will picks up render, and then when you switch to your viewport, what it should by default pick up is the proxy, but you can force render on in the viewport as well if you want to. And this ideally is just designed to eliminate high resolution geometry. If I go into my wireframe, imagine, especially like the barrier that was really high res, you could do a proxy version of the barrier just to display in your viewport. And as soon as you hit render, then it will actually switch to the render time version. So this is something that's really nice to optimize your viewport display. If you want to see the purposes in the scene graph tree here, there's a little gear icon here. And you can see there is some stuff here, so like variants, and you can see here's purposes. And if I click that on, you can see there's a purpose drop down here. And by default, if there's nothing assigned to something, it's called default. But you can see there's a proxy surface and a render setting for this geometry. So you can see in the proxy there's actually no geometry, and that's why we're not seeing anything if this is if the render time is off, so there's nothing there to display. Alrighty, so the next thing what I'm going to do is just open up a shot here, and what I'm going to do is just open up, go to my, in the LOPs network, the shots, and this is the lighting setups for the shots. So I'm going to go to shot 2 here, and let's just open up this one. And as you can see, we just got pretty much a long line of stuff. So this is obviously a fairly clean workflow, and that's because we've saved out all the objects here as USDs with the materials assigned to it. So it's really nice. So starting out the top here, we've got this scene import, and this is a sublayer or just a file node that you can load in. And we've saved out this scene structure USD. Now just selecting it and viewing the scene graph tree here, you can see there's nothing in it besides pretty much just a directory structure if you look at it that way. So we've got our root and render, we've got our world. In our world, we've got our camera effects, and we've got geometry, subcomponents of geometry, so crowds, environments, props, vehicles, and then we've got a lights down at the bottom. So going one step down into our sublayer, as soon as I select that, you can see now under my camera, I've got this camera 2. Now the camera is coming in from a scene import, and this scene import is pointing to a object level scene camera that's been imported. So if we go to object level, we can see we've got a camera. It was originally a limbic camera, but this has been actually baked into the scene, and it's been scaled down to match Houdini sizes. So there's the camera, and if I just go back here, we're importing scene import, filtering by cameras, and we're just pointing to that camera. And then just on the scene import, the destination path, this is set to world or root world camera. And when we sublayer this in, what happens is it puts it in the appropriate directory structure from this level. So moving down, and let's view this little hanger. So this is, well, let's say not a little hanger, but this would be the entire outer scene. It's actually quite large, but yeah, so this is the hanger with the setup. So you can see under the destination primitive, we've got root world geometry environment and $OS, which is referencing hanger. So if I look in my setup here, I've got under the environments, I've got my hanger here, and under that we've got our geo, and we've got our materials assigned to everything already. So that's really handy. Then we go down and we've got some configure stuff here. So this is really just to, it says configure displacement, and we basically targeting the geometry, specifically the ground here. And if you scroll down on this section, you can see we've changed the dicing quality of the displacement, and a higher dicing quality means you get a finer level of displacement. The render time geometry will dice up into a finer level, and you'll get more detailed and high resolution displacement. That's obviously at a render time cost and memory cost. And then we've got a walls as well that's configured to displacement, except this is got true displacements disabled. And this disabling the true displacements basically acts like a bump map. So you'll get quite a nice quality looking roughness or map on here, except it's not truly displacing. So you won't see, if you look at it from an angle, it will still look flat. All right, then moving a little bit further down, now here we've got our soldier coming in. So let's maybe look through our camera and see if we can see our soldier. So we currently can't see him. So let's have a look at our sunglasses. We've got render on. So you're wondering now, well, why is my animation not in? Well, in fact, that we've actually got the soldier in here. Let's just zoom in on him. And he's sitting here at the origin in his rest pose like we saved him out as this USD file. So now what we can do is we can bring in, like I said, a sublayer. So here's another reference coming in, and this reference is pointing to a USD that's been written out. So the first part of this is just referencing the actual soldier above. So you can see it's referencing this specific primitive that's sitting up here, the soldier. And then the second one is a file pattern, and this is just pointing to our shot2 USD, animated USD. And if I view that, and you can see now immediately I've got the animation applied to it. If I scrub backwards and forwards, the animation's coming through, and you can see it's actually quite responsive as I'm scrubbing backwards and forwards. And that's the nice thing about USD. It's pretty quick with animation caches and stuff. So that's quite nice to see. Now you're obviously asking you, where did we get this USD setup? So if we come over up here to the shot on the side here, we've got a mech anim and a soldier anim. And this is a separate little LOP network that's been set up. And if you dive inside here, what we're actually doing is we've got a process animation. So if I dive in here, this is going to error out at the moment, and that's just because my path is wrong from the original. But this is bringing in shot2's animation that was saved out from Maya, and that's in a limbic file. You can see it .abc or a limbic animation. And we're doing some just basic operations again onto the mesh just to align it up to all our settings, making it correct. So nothing special being done here. It's just really bringing in the animation, getting the names the same as the static one we've saved. And as soon as you then go here, we're saving the animation out as this USD once we've done the prep work on it. So now we've got an actual USD animation. And another thing that's nice about it is when you're saving out a USD animation, you actually get a better motion blur. So let's just render this guy and give it a moment to kick in. So I'm just going to disable the lighting up here and deselect my soldier. So you can see his motion blurring there. Camera's got a bit of motion blur as well. So what happens if you bring this character in from SOP level? So if you do a SOP import, for instance, a SOP import, and you bring this character in, the motion blur won't be correct. And that's because the SOP import doesn't interpolate the USD directly. So you have to pretty much import the geometry. So if you look here, we've got our processed animation. We've basically importing the limbic and doing some stuff to it. And then we're writing it out basically as our USD. And then that does a proper interpolation of the mesh as it's writing out. You can, if you're doing a SOP import, you can get the motion blur to work, and that would involve doing a cache node and plugging that in. And there's some options there. There's also a motion blur node, which you can use. And this is actually just a HDA with some other options, which uses the cache. So if you dive inside here, there's a subframe cache here. You can see that's on with some additional stuff. So that's the option if you want to just make sure your motion blur is working a little bit better. Just wanted to show that. But yeah, ideally you want to write out your USDs to file And that way it's a lot more optimized to work with as well. It's quicker than trying to read in your entire setup from SOP level, and it's got to cook your SOP level and then bring it and convert it on the fly to USD. So this would be a lot better to do it this way. Then I've just disabled that. So then we've got, just going down to the rest of the scene, we've got some additional setups. Got this little truck proxy. There's a couple of them placed around the scene. We've got our barrier here that's come in. And as you can see, as I'm kind of selecting them and scrolling through here, you can see these have been populated by with the additional setups. So just selecting that down towards the end. And just, so some of these stuff's now missing from our render. There we go, we're viewing it again. So sometimes the cache just breaks when you're just selecting it through. So you need to maybe disable a node and enable it again just to make sure it's working. But yeah, we've got all these assets coming in. And again, what's nice about them, they've all coming in with their setup that we've set up with the materials and everything attached to it. And then we've got our shot lighting down here. This might work, should work. It's got some setups going. And let's just enable the lighting. And let's just give this a moment to think about it. And there you can see we're starting to get some renders with some lighting happening. And then obviously we've got, yeah, further down we've got our camera over here. So this would just be another camera override. Not necessarily needed because we've got the one up here. And then we've got some additional render output passes so we can render different parts of the setup. So we've got a background render and then the main shot beauty, and then we've got a fog render as well, just to create a little bit more depth in the render. And that's got its own set of lights and stuff. So that's what I wanted to show just as far as the one of the shots go. And yeah, so all the setups are the same. You can see these shots end up being fairly simple. You know, you don't have to manually assign shaders to each shot. You can just bring in your assets and populate it from there. And yeah, so next we can just have a quick look at some other little parts of the USD workflow. I specifically wanted to just look at how we treat bringing in a limbic if we don't bring it in like this, what the paths look like over here versus adding custom names. And then we can look at some point instancing options as well, how the point instancing works in USD. Hi there, just taking a look at how we would treat the soldier geometry if we're bringing into USD and the different options we have. So I've loaded up the SOP network here. I've got the limbic animation for the character that I've just brought in instead of a static. And this is pretty much a straightforward network. So I've got my limbic file here. And then what I've done is I've got this convert node, and this is basically doing an unpack. So if you look at the middle mouse on the limbic, you can see I've got 88 packed primitives, and they are limbic primitives. And then I'm unpacking it, and you can see now I've got the full geometry exposed. The one thing I've just left on here in this little setup is there's a normals issue. Let's just zoom in on this guy and take away the wireframe. So you can see when this was exported from Maya, there was some normals issues. So these have been reversed with a manual selection. So I've just kept that in there, and then new normals applied to those as well, just to be sure they're working properly. And then scaled down to a Houdini scale, so 0.01. And that's what's, yeah, I'm just bringing that in. And let's have a look and see how this comes into USD. So I'm going to jump out here. I'm obviously still in my stage context. And like I said, we've got that pre-built setup for the assets, but let's use the component builder. You could do it this way, and you could bring in your geometry like this. The other option is to do a SOP import, and we'll have a look at both. So just going back to my animation here, I just want to copy this anim null here, and let's just go to the component builder. Now the component builder, on the source here, there's a source internal geometry. So if you dive inside, you've got obviously your options here. And if you wanted to do anything to the geometry, you could do it over here. But we could also just switch the source internal network to a external SOP network. And that would be this one here. So we just need to paste in that path that we built. And you can see immediately now I'm viewing this output. I've got a whole bunch of stuff happening. So the component output here is obviously our robot. So you'll look at the asset and it will be named robot, and we've got this subfolder with geo. And if you look inside here, we've got all these names, and there's a whole bunch of them, which actually represents all our alembic paths. And this would be, if you added them up, there will be 88 groups here, essentially, if you want to see it as groups. But the reason why this is happening is because if we go back to our setup here and we dive inside and just have a look at our spreadsheet under the geometry, we've got this alembic path. And even if we look at it before we unpack, we've got this whole bunch of paths, and they all represent these alembic path shapes. And so it's giving us this explicit path with these random names. So they're not very nicely named either. So not entirely useful for us, but you can see those are coming through just since it's seeing a path attribute, those come through. So the same thing is if we paste our path over here and we look at this setup, you can see now, well, we've got the SOP import, and it's actually creating a whole bunch of geometries for us. And this is really even worse. You know, instead of this, we've at least got a robot geometry here with a subfolder. The SOP import is just putting them at the scene root. And even if I change this import prefix, so if I possibly add robot here, let's see what that does. You can see actually nothing happens in this scene graph tree. And that's because the path attribute is actually overriding what's happening over here. So one way around that is to basically delete the path attribute. If you had reasonable names on your robot or your incoming mesh, you know, you might want to use those groups, and then that would be fine. So just having a look in here, maybe we can go to the alembic, and we can say on the alembic to import groups, and let's use this shape name just to see what it does. And I press information in here, you can see now we've got a whole bunch of groups going on. And you can see, as I say, the names here aren't really great. They don't really mean much. So pretty much useless to us, unless we have specific shaders that we wanted to assign to certain things based off this, but I don't see that you would ever want to do that. You'd probably want to get the assets department to name reasonable things. So we've got like the body panels, we've got these maybe these like hydraulic rods here that would be, you know, these would probably be chrome or something, and these black pipes maybe rubber. So you might want to separate it out like that, for instance, at the moment. So our grouping isn't really helping us much. So then just what do we do? So you can come in and you can actually delete this path. And if I just delete the path attribute, so this will be a primitive attribute that it's on. deleting that, and let's go back to our stage and viewing this. And now you can see I've got my robot that's actually popped up here. And if I expand this, there's a sub import, which gives us this name. And then there's just a mesh one, and this is pretty much the whole mesh. The same if we go to the component geometry here, the setup that Houdini supplied for us. You can see we've got the breakdown, we've got our robot, which we've called here, and then there's a folder with a geometry, and then just this shape. Obviously this isn't ideal because there's no specific names to that. Now another thing what we could do to take a step further is we could use a name attribute, and we could give this mesh a decent name. So we could call this robot underscore geo maybe. And if we go back to our stage here and to this, you can see now our geometry is actually called robot geo. Let's just call this sub import robot, just so the name's clear over here. And obviously we've got a / robot, so we could even take that out, and then we'll have this. And this could be our robot geo. If we look at it there, robot geo, so the name stays the same. The other thing we can do is if we want to manually create groups, is we could come in and, for instance, well, we make our manual groups, and hopefully, like I say, assets would supply you with some groups. But for now, I'm just going to do some temporary groups. So these are just going to be rough. So maybe we can make some arm groups here. I'm going to hit tab and type group. And let's just call this primitive group arms, like so. And let's do a selection, and maybe we can do some leg selections here. Just roughly doing this. Obviously don't want to waste time doing exact selections. This is just to show you how the names come about and across into the LOPs level. So hitting group here again, or I can just go here, and let's call this legs. So now we've got these two groups, and again, if we go back to SOPs or to the LOPs level, you can see, well, those aren't really coming through in any way. They still got this name attribute that's robot geo. So those groups are meaningless, and you could bring them in. There is a, under your geometry, I think it's under this geometry level here, there was a groups selection that you can bring in. Apologies, it's under import data, and you can specify subset groups. And as soon as you do that, you can see you've got your geo, and then under that you've got your arms, which is a subset, and that actually comes in the primitive type. You can see it over here. Now the other way to do it is to actually bring it or create the names from it. So you actually, instead of getting just this name, you'll get a bunch of names for the parts, and we can do that quite easily with the name attribute. So instead of just using this name like this, we can say name from group, and since we've got these groups that we've set up, we can just say star, and then it will create names. Let's just clear this original one out. And having a look at the spreadsheet here, what's happening, you'll see there's some blank stuff. But as I scroll through here, you'll see there's legs and there's arms. And yeah, so the blank stuff is obviously we've only got these two groups, and we're missing a whole middle section of the, so there's nothing assigned to it. So what does that look like? If we go to the stage and I go to my SOP import, you can see now I've got my arms and legs. So those are actually coming through as separate pieces of geometry almost. And that's really useful for shading if you've got specific things like, say, the pipes and etc. And then the one that's unnamed just comes out as mesh naught. And then again, looking at the component builder, if you look at that, the exact same structure under this geo will have this arms, legs, except this time it's named shape. But the structure is pretty much identical as far as what you're bringing, what data you're bringing in. So if you specifically want to do, quickly make a group out of that, we could use a group combine. And let's just put this up here. And let's call this body. And we can say equals, well, not equals, equals all but. And you can see we're starting to get a inverted selection there. And we want to say maybe subtract width. And we can do legs. And as soon as we do that, now we've got a body group, which is everything. So we've got our arms, our legs, and then our body group here like this. And now we can simply go here to our name. Since we've started this, it will already automatically create that name. So we can see we've got body here. And now there's no blank areas within this naming convention if you scroll through the whole setup. So going back to our stage, going to our SOP import, you can see now I've got my arms, body, and legs coming in. And the other thing you could do is if you really wanted to, is you could go into this name attribute and you could actually, well, it's not going to work in this case, but you could actually put a / in there. So if I, for instance, just created another one just to show you, let's just call this robot, and you could go / body. And this is going to obviously override these name attributes that I've already created. So now we'll just have this. But if you go to the stage now and you look at this, you'll see it's actually taken, it's created this subdirectory now with the mesh in. So now I've got robot body pretty much like we've named it. And I could maybe create this as, say, test, even go deeper. So this is like creating directories almost. And you can see there, robot test, geo. This likewise under this geo, we've got robot test, body. And yeah, so that's how you can quickly, generate your own levels of paths, or instead of using paths, and create your own custom look. Much better to assign a shader if you don't have, proper groups coming in. You can manually create them and use the name attribute quite nicely. The next thing I want to just quickly touch on is the motion blur aspect of this. I'm rendering this frame now, and if I go backwards and forwards a little bit, you can see as the robot's moving, there's no motion blur here. And let's look at that in the next video. All right, so one or two ways to treat the motion blur. You can see I've got my render going here. First of all, we want to drop a karma ROP just to make sure we got the settings, and really, you don't really need to do this, but just to show you that the motion blur is not working still. So you can see on the karma ROP it is on by default. I'm going to turn off depth of field for now. And yeah, so this is obviously not working. Now what's happening is this SOP import, when you're importing directly from SOPs, the USDs don't interpolate between frames. And I'm not too sure why this happens, but it's just a default setup. So the one way to do it is to actually write out your USD animation, and that's kind of like we've done in our assets build of the character, etc. And the only problem is, if you do it on a sequence like we wanted to do, so you've got our robot here, you can't write out a sequence over here on this component builder. This is for your static object. So you would have to, like we did with the setup, you've got your robot in rest position. This would be the asset saved out with the materials on. Then you would need to write out a separate USD potentially from here to disk, and that would then you would read that back in, sublayer it into this setup. The other way to do it, and we'll do that in a second, but if you went back into your animation, we can actually do a USD export directly here. And obviously, once we've got our assets set up and we make sure all our names are correct, we could potentially just do it from here as well. So just looking at these settings, this is very much like the SOP import. We can go to export. I'm just going to export, maybe a couple of frames just to check. So maybe 160. Let's just current frame range, and go ahead and delete this. And let's go to 160 to maybe 180, a little bit more room to play with. And then the path we want to output is this output file here. For now, I'm just going to leave it kind of default and take away the hip name. And we're going to just call this robot SOP export. So we've just got a clear name on it. And then I'm going to save this to disk. Should be quite quick. And that's done now. So now we can come back to our stage level. I'm just going to middle mouse and copy this setup. You could probably use the hip variable here as well, but we should be using job actually. And let's do a file. And then this will come up with a couple of options. So the easiest one just to use is reference sublayer. We can use if we're sublayering in the animation into the setup, but for now we're just loading it in straight. And let's go to the file pattern here and paste our path. So we've got that USD coming in, and let's view that now. And you can see immediately, without doing anything, I don't even have a karma ROP attached to it. We've immediately got our motion blur working. So that's really cool. Yeah, like I say, we just need to have that. If you don't want to specifically write out your USD every time and you're doing a bit of R&D and you want to use your SOP import, what you can actually do is you can use a cache node. And just viewing this, you can see nothing happens, but what I can do is turn on subframe data, and this will give us basically a shutter open and close. So when I look at this one and I switch to this one, you can see the motion blur is actually identical. So this is a nice way to, if you're deving, keeping stuff alive, just use your cache mode. And so if you've got a camera, you can actually point your camera and it would use the shutter from the camera to do the motion blur. So you would get better motion blur through the camera as well. And lastly, we could obviously, instead of writing it out at SOPs level, we could do a USD ROP over here as well. And we could just write this out. We wouldn't need the cache node. We could write this out. So this would be handy, obviously, if you've done, a assigned material on a setup and you've got some materials on it into your object as well. And then you could just save this out over here. And let's just change the name. So I want to maybe just say USD robot. And let's just do the same frame range. Just want to check that this is actually still working. 160 to 180. And then we could just ROP that out pretty much as it is. And this should work like so. So now if we go back to this file, let's copy and paste this and bring in our setup here. So we want this file over here, copy, paste this. And you can see indeed there, it's written out and the motion blur is working. So, and then this will have your naming. So yeah, just have a look at that as well. So that's the kind of 3 ways you can look at using the motion blur properly in USD when you're rendering with Karma. Hi, so just having a look at the instancing types of setups that we can bring into LOPs. I've created this simple particle system with these little bits of debris scattering. We're going to be doing a similar setup within the course. I've just modified this one just to be quite simple and just to take you through the base setup. So I've got a curve, resampling it. I'm exporting my curve view attribute. And then I've got this orient along curve, which is basically giving me the normals in the direction of the curve. And then in this setup, what I'm doing is I am creating a, using the curve view, I'm creating a little animated section. And that's just quite a simple setup, just animating this fit range with this ramp that's fit like this. So you could expand the emitter up and down a little bit if you wanted to. And then I'm adding a point replicate just to scatter points around the current setup. And this is just using a circle with some noise on it. And then after that, I am creating some velocities. And it's basically using the normals that we created here. And inside this, this is one of these setups we'll be creating later on. But essentially what I'm doing is I'm mixing between the normals and a up vector. And you can see my normals down here are pointing up. They weighted a little bit more to up than to the side. So you still get the direction of the travel a little bit. And you could dial this in and out to get more of a direction. You can see as I do that with these random attributes, it will orientate itself a little bit more in the direction where we're going. And then I'm just blasting out the emitter area. So that is this setup over here. I'm exporting a bind emitter. And then, yeah, just running it through a basic particle setup, PopNet. Yeah, having a look at that. Let's just turn off these visualizers. And yeah, very straightforward little particle setup just to demonstrate this system. But inside here, I've just got my source, and that's set to all points. And then I've just got a pop property just to limit the bounce and the friction here. And then there's a ground plane and obviously some gravity. And after that, I've got a randomized p-scale. I'm cleaning up some attributes. And then I'm adding my variations. We've got these little rock setups on this side. And let's just have a look at that quickly. So we're taking a box and we basically using the Voronoi fracture, scattering some points here and doing that. We're doing a bit of a jitter on it to create some noise, remeshing it and then jittering it again. So it's quite noise, and then just smoothing it out. So we've got these kind of rough rock shapes. And if you middle mouse on here, these are just, points and primitives. And what we can do is, because these are separate pieces, we can use this assemble node, and that's quite a handy node just to do things quite quickly. But it's basically a simplified version of doing like a for each connected piece. So each connected piece will become a pack primitive. This is set to pack primitive. So if information here, I've got these 2,628 primitives. If information here, you can see now I've got 27 packed geometries. And that's quite handy. So they obviously, you can see they're packed and they're all kind of in their own space. And to efficiently work for the copied points, we need them all to be at the origin. And there's a simple little hack here on the wrangle here, and that's setting our P to 0, and it basically brings all the packed geometries to the 0 origin. And then we've just got this enumerate, and this is creating our output variable for our copied points. And you can see we've got 26 here set up. And then on our copied points, we've enabled var. And then on the side is the variation amount. So basically taking each ID number of the particle system and modulating it by 27 to give us that. So I could reduce this down to, 2 or something, and then I'll only get 2 variations of the output here. You can see if I just have a look at the spreadsheet under the name attribute, which is coming from here. So the rock assemble, I've changed this to rock, and you can see we've got rock 1 to 20 or 0 to 26. So there's 27 of those. And then just looking at that, so if I've limited my variation to 2, I've got this rock 1 and 2, or should be 0 and 1. This is probably should be 3. And yeah, so we'll have a bit of variation happening. It seems to be just locking out at a much lower value. But yeah, so let's just up this a bit. 10. And you can see this, well, in fact, there's actually something wrong here. So what I've done is, sorry, I've deleted out my ID attribute here by accident. So I need to just bring that back in. My bad, sorry. And yeah, so then we should have some rock variations now. So yeah, if I bring this back down to that 3, we'll only have 3 rock variations that's been copied if you want to limit the amount of instancing that you're doing. So let's just make it 10 so we've got a better example. And then, yeah, so that's it. So like I say, these are packed geometries coming in. So we've got now all our geometry packed, and let's have a look and see how that comes out in LOPs. So I'm going to go up to this level, and what I'm going to do is do a SOP import. And let's just go back in here and copy this out. Control C that, and Control V over here. And you can see now we're bringing this in. I've got my render enabled. And yeah, those are coming in quite nicely. Now, if you look at the SOP import, we've got the name here, SOP import. So this is obviously this name. So let's just call this articles, just to give it a different name. And then you'll look in here, you can see you've got this prototypes, and I've got my prototypes. There's 9 prototypes. So we limited that to 10. So we've got 0 to 9. So there's 10 prototypes. And then over here, you can see there is the, basically this is the instance of each of those prototypes. So there's rock 0, rock 0 is rock, and if you scroll down, you'll get now to rock 1, and then each instance of that rock 1. And this isn't bad. Let me just pause this render here quick. You could essentially come in and do little selections here. Don't remember exactly offhand which one you can select, but you can basically come in and select individual rocks if you wanted to, and apply specific things to it. You could transform them, but obviously this isn't really ideal to do this in a big particle system. What I do find this setup is fairly messy. You've got all this, you've got your particles, and we've set it up in SOP so to be instancing. So there's another way we can actually load this, and this will treat it more like a Houdini style instancing. And if I go to my SOP import and my primitive definition, I can do this packed primitives. And you can see nothing changes if I enable this. But what I can do is I can go to create point instancer, and you can see everything immediately disappears. And now what's actually going on is we're just using the point instancer. That's kind of a better way of doing it, in my opinion, for this kind of thing. And then we've just left with our prototypes, and you'll see here's all our prototypes. So now when we can't come in here and select individual rocks anymore, they kind of all combine. But what you would do is you would assign your shaders to these prototypes, and they would just populate through that. Even if you've got the native setup, you assign your shaders essentially to your prototypes. So I just wanted to show that from a pack primitive point of view. You can see it's fairly quick in the setup. And now what I want to do is just hit a bit of a render, and let's look at the motion blur side of this thing. So if by default render, we can see we've got no motion blur happening. And in fact, if I do a camera op, and let's plug this in, we don't have a camera, so it's going to give us that warning again. And still nothing really happening on this. Now you could try use a cache node on this, but that's not really going to work very nicely for particles, because the particles are changing. You can see we're getting all these weird streaks and stuff. So we don't want to cache the particles. What we need to do is we need to use velocity blurs. And on the camera settings, you'll see under the camera effects, let's turn this off. There's our motion blur. You can turn on motion blur here, but nothing's actually going to happen. So what you actually need to do is create a render geometry render sub. So, or LOP rather, geometry or render geometry settings. And we want to, at the top here, we want to target our instances. So we can just probably drag the particles in here. And then the next thing what I want to do is I want to enable my velocity blur. And I'll set this on. Now you can see still nothing's happening. And essentially what's happening now, because we've actually instanced this, this velocity blur doesn't work. So we need to go a little bit further down here, and you can see there's an instance velocity blur. So I'm just going to disable this and go to the set and create, and I'm going to use this. And now you can see we're in fact getting our velocity blur in from on our instances. So that is the little bit of a gotcha you got to kind of be aware of when you're bringing in your instances. And yeah, just wanted to show that off. I think it's quite handy to know. Next, we're just going to look at how we can export this from SOPs, and then maybe we'll have a look at how we actually assign shaders, like I said, to this instancing setup, and to make sure they're working properly. Okay, so I'm just going to pause the render here, and then I want to write this out from disk at SOP level. So I'm going to dive into my SOPs, and I'm going to create a USD export again, drop this in here, and then let's just do a couple of frames, maybe to 55 or so. We don't want to spend too much time writing this out, even though it's quite quick. Just keep it quick and simple for the demo. And then we want a reasonable name, so I'm just going to call this SOP underscore particles. And let's just take out this name here and write this to disk like so. So basically the default settings. And then let's just bring this in. So I'm going to copy this path, go back to my stage, and let's use a file again, and we're going to reference it in. And under my file pattern, paste this setup. Now having a look at this, it's come through, and let's have a look at the render. And you can see now it's actually working quite nicely. We don't have to do any specific settings or anything. It's just working. So the next thing what I want to just have a look at quickly is this directory here. And you can see as we've brought it in now, it is the native instancing setups. Again, we've got our prototypes and then all the USD instances. And there's no settings to change it when you bring it in here. This is just making the whole thing instantable. And so we need to actually export it with that value. Much like the particles import, we've got this primitive definition. So if I just go back to my object level, just go to my SOP level here, and then to this USD export under the configure, there's a primitive definition over here. And you can see the same options up here. So we can click this on and let's generate the point instancer. Now I'm just going to write this out again like this. And let's go back to this side and let's see if we've changed anything. So if you look at the file now, it's automatically updated. We've got our instances here with just our prototypes. So now this is the point instancer coming in. And let's give this a render again. And now you can see, well, now there's a little bit of an issue. And this is just a little bit of a gotcha with the point instancer and writing it out at that level. Is it now tries to interpolate the geometry instead of the seeing the instances itself. So this is now using we need the instance velocity to work instead of the normal velocity. So we can simply just come here, we can redirect this name from this primitives. So we want to be using our SOP particles, and we can view that. And now as soon as we view that, again, we've got our instance motion blur, and now that's working all correctly. The next thing I just want to do while we're here is just do some shader assignments, and we can see how we can add the shaders to these instances and how that works. So I'm just going to move this up here, and I'm going to drop a material library up here. Let's just put it at the top of the stream, dive inside, and I'm going to do a comma material builder. And just diving inside it to this, you can see the actual shader setup. So the standard surface Karma uses is the Material X standard surface shader. And let's just give this a color so we're making sure we're assigning the shader correctly. So going back up to my stage level, and then I want to do a assign material to assign it. And I have to do that obviously after I've imported my data. You can do it anywhere underneath, as long as it's obviously after, because it's a top-down approach. And we can simply drag and drop our instances. You can do it at this level. So it basically takes everything at this level down, and we'll assign a shader to it. And then what I want to do is just create my material, drag this in here as well. And you can see immediately now I've got that material assignment. Now, obviously, like I said, this is assigning to everything. What you can actually do is you can actually assign it to just individual prototypes. So I could potentially just select rock 0, and you'll see this is all the instances of rock 0. And likewise, we could go to 7 or something like that. And these are now all the instances. So you could easily come in here, and if you wanted different shaders, possibly different objects within this setup, you could come here quite easily and assign the shaders as well to that. And if you had different names in here, you could assign them. So like, for instance, I could do star here, and anything with a rock star would have the name in. And if I had, for instance, stones here, or bricks or something that were instances as well, and I could just create another shader and assign maybe something like that. So worth noting that you can do that. And again, like I said, there's a top-down approach in this. So just checking, like looking at this now, so I've selected all the rocks and assigning this shader to it. But what happens if I've added now a second one and I just want to target rock 3? Well, let's have a look at creating another material. So I'm going to duplicate this and change the color to something else like blue. And let's come here to the assign material, and I want to add this material on here. So you can see I'm actually overriding what was assigned above it, and that's quite handy. So you can just continue down the chain, you can override the materials as you want further down the line. If you feel the need, you have to do that for shot-specific reasons or something. It's a really handy and quick way to assign materials, especially if you're doing out like different render passes and stuff. Then lastly, just wanted to have a look at, we've got some data that we're bringing in here with these instances. So for instance, we've saved out our age attribute with these little rocks that we've saved out. So we can actually utilize that in the instancing as well. And that basically gets copied onto all these instances. So in my material library, let's just go to our original material here. I can do a geometry property value. And for instance, let's just control the base color. So the age attribute that we have is a float. And so I'm just going to say age, and that should come in. And let's just plug this straight into our base here. And you can see immediately what's happening is it's changing the base color from 1 to 0 based off the age of the particles. Obviously, this is kind of inverted. You'd imagine possibly you would want this the other way around, or you want to mix two different colors. So we can do that quite easily. We can do a remap, attribute remap, and you can fit this range a little bit as well. You can squash the values so the transition is tighter, and you can swap these two values around and control it like that. And like I say, you can do a mix as well, MTLX mix, and we could plug this into the mix node. And for instance, well, this wouldn't be color now. You would want to control your color. So you would change your signature to color, and you can do a foreground color and then a background color. And then now we're controlling the color range in the shader by age and fitting this into a tighter squeeze or a longer setup. You can get that quite interesting look going quite easily. And then obviously you could randomize this, etc. You could bring in other attributes and you could go wild. So really handy. And as you can see, we've still got those little blue particles sitting in there. So that's what I wanted to show, just with the some assignments and the instancing and the motion blur side of things with the instancing. So yeah, let's move on to actually getting into the course now. We've got quite a bit of stuff to cover.